This video is a set of audio flashcards for the soil science chapter. I'm going to read the terms, wait a bit, and then read the definitions. If it's going too fast or too slow, you can click the settings in the video and change it, or you can pause the video after each term to come up with your answers before I go on. Aggregate. In soil science, an aggregate is a cluster or a mix of small particles of different sizes that are bonded together. The aggregate can be made of organic matter or soil particles. As aggregates form, the soil structure improves. Air excavation device. An air excavation device is a device that uses a jet of highly compressed air to remove soil. It's useful when you're looking to avoid damage or reduce damage to tree roots, underground structures, or utilities. Anion. An anion is a negatively charged ion. Buffering capacity. A soil's buffering capacity is its ability to reduce changes to its pH. Bulk density. Bulk density refers to the mass of an object divided by its volume. For soil science, the bulk density reflects how compacted the soil is. The higher your bulk density, the more compaction there is. It's often measured in grams per cubic centimeter. Capillary water. Capillary water is the water that stays in the smaller pores in the soil after the rest of the water has drained out under gravity. Capillary water can move in any direction, and most of it can be taken up by plants. That part is called the available water. Cation. A cation is a positively charged ion, which tends to be attracted to the negatively charged surfaces of soil particles. In the soil, the most abundant cations are calcium, magnesium, potassium, sodium, and aluminum. Cation exchange capacity. The cation exchange capacity, or CEC, is a soil's ability to hold on to cations, or positively charged ions. It's affected by the pH and the size of the soil particles. Certain cations are more available at different pHs, and the smaller the soil particle, the higher the CEC, because there's more surface area to hold the cations. Some of the cations are nutrients, so a higher CEC means more soil fertility. Clay. Clay can refer to soil particles that are smaller than 0.004 millimeters. It may also refer to a soil that has enough clay particles to take on those properties. A clayey soil feels sticky when it's wet. Compost or composting. Compost is organic matter that's mostly or completely decomposed after it was specifically set up for decay by humans. Composting refers to the process of setting up that organic matter for decay. And compost is also a verb to describe the process. For example, I'm going to compost the leaves. Field capacity. The field capacity of a soil is its moisture level right after water drains out under gravity. Once the soil starts drying further, it's no longer at field capacity. Gravitational water. Gravitational water is a water that drains out of the macropores of a soil under the influence of gravity. Once the water has drained, the soil is said to be at field capacity. Ion. An ion is an atom or a group of atoms with a charge. It can be positive or negative. A positively charged ion is a cation, and a negatively charged ion is an anion. Leach. Leaching is a process where elements or compounds are dissolved in water and washed into the soil or deeper into the soil. For example, after fertilizer is applied, irrigation water may leach the nutrients past the roots of a tree. Loam. Loam describes soils that have a certain ratio of sand, silt, and clay particles that has the best of each of their properties, which makes it ideal for plant growth. It is used to identify soil texture classes, for example, clay loam or silt loam. Macropore. Macropores are relatively large spaces between soil particles that are usually filled with air. When the soil is saturated, they may be temporarily filled with water. Water moves quickly through the macropores, and they allow space for root growth. Micropore. Micropores are relatively small spaces between soil particles that hold on to water for plants to take up. They're often found inside soil aggregates. Mineralization. Mineralization is a process through which chemicals inside organic matter are decomposed or converted into inorganic forms that plants can use. The study guide's definition is mineralization is a process in which an organic substance is converted to or trapped in an inorganic substance. Mycorrhizae. Mycorrhizae, plural, refers to the mutually beneficial relationships that happen between certain fungi and the small absorbing roots of the plants. Those types of fungi are called mycorrhizal fungi. Nutrient cycling. Nutrient cycling describes how mineral elements, for example nutrients, move through an ecosystem as the organic matter breaks down. The nutrients are released back in a form that plants can use. Organic layer. The organic layer is a layer of organic matter that's found at the soil surface. It is another name for the O horizon when you're talking about the soil profile. Organic matter. Organic matter is any material that comes from the growth and death of living organisms, like plant debris, animal excrement, and carcasses. This is what makes up the organic portion of the soil. Parent material. The parent material is a base material that soils are made from. It can be the bedrock where the soil is located, or it might be material that was brought in from somewhere else by wind or water. Permanent wilting point. The permanent wilting point is the soil moisture level at which a plant can no longer take up water from the soil. If water is not immediately provided, the plant will permanently wilt. pH. pH is a chemical property that describes how acidic or alkaline a soil is based on the hydrogen ions that it contains. The pH scale goes from 0 to 14, 7 being neutral. Below 7 is considered acidic, and above 7 is considered alkaline. The pH scale is a log scale, meaning that each measurement has a difference of 10. A pH of 6 has 10 times more hydrogen ions than a pH of 7. Pore space. Pore space refers to the voids found between solid soil particles. They can become filled with air or water, and roots can also grow into them. Rhizosphere. The rhizosphere is a narrow zone surrounding roots, and it has different properties compared to the soil just outside of it. It also has a high level of microbial activity as a result of those different properties. Root exudates. Root exudates are substances that are released by the roots as they grow, and it includes sugars, mucus-like substances, amino acids, and more. The exudates change the environment right around the roots, creating the Saline soil has a high concentration of soluble salts, which can affect plant growth. To mitigate saline soil, you have to flush the soil out with a lot of water to leach out the salts. Sand. Sand refers to the largest particle size that affects soil properties. It has a diameter between 0.06 millimeters and 2 millimeters. Sandy soils will feel gritty. Silt. Silt refers to the particle size between sand and clay, and it measures between 0.004 millimeters and 0.062 millimeters. A silty soil will feel smooth when it's wet. Sodic soils. Sodic soils have relatively low levels of soluble salts, along with high concentrations of sodium. The sodium damages the soil structure by breaking apart the soil aggregates, which leads to waterlogging, erosion, surface crusting, and poor plant growth. To mitigate a sodic soil, add gypsum to replace the sodium with calcium. Then flush the sodium out with a lot of water. Soil biological properties. A soil's biological properties are determined by its living organisms, such as the fungi, bacteria, nematodes, worms, insects, and other animals. Soil chemical properties. A soil's chemical properties are determined by the molecular content, basically the interactions and reactions that happen at the surface of the particles and in the surrounding water. They include pH, cation exchange capacity, buffering capacity, and more. Soil compaction. Soil compaction occurs when the soil is compressed by weight, including from foot traffic and heavy vehicles. Soil aggregates are broken down, which reduces the soil volume and the amount of macropores. Soil food web. The soil food web describes a network of food chains that happen within the soil. Soil horizon. Soil horizons refer to horizontal layers of the soil. They may not be visually different, but will have different physical, chemical, and biological characteristics compared to their neighbors. Soil physical properties. The physical properties of a soil are determined by the size and the arrangement of the mineral particles. They include texture, structure, bulk density, and more. Soil profile. A soil profile is a vertical cut or section through the soil which exposes all of the soil horizons. Soil structure. Soil structure refers to the individual soil particles that are arranged into larger clusters. The larger clusters are called aggregates. Soil texture. Soil texture refers to the sizes of soil particles that are found in the soil. The most important ones are sand, silt, and clay. It is not practical to try to change the soil texture. Structural cells. Structural cells are 3D modular units that can be combined to provide support for paved surfaces. Since the cells themselves provide the structure, you can use good quality loose soil inside the cells to enhance root growth. Structural cells can also be used to retain storm water on a site. Structural soil. Structural soil is an engineered medium that is used to support pavement. It contains angular rock and soil. Hydrogel might also be added to the mix depending on the recipe. The angular rock allows the medium to be compacted as much as needed, while still leaving space for roots to grow through. An example of this is Cornell University's CU structural soil. Suspended pavement. Suspended pavement rests on top of an engineered structure instead of right on top of the soil, so the soil can be uncompacted and high quality. The load is transferred through the structure to the subsoil underneath. Symbiotic. A symbiotic relationship is a close and long-term interaction between organisms. In the study guide, it's defined as being beneficial to one or both parties. More broadly in biology, there's 3 different types. There's one where both parties benefit. There's another one where one party benefits without harming the other. And in the last one party benefits at the expense of the other one. Water holding capacity. A soil's water holding capacity is its ability to hold on to water that enters it. A well-aggregated soil with a lot of micropores will be better able to hold on to the water, which is then available for plant use.